Hey kids, it is time for a new lesson. So we are still on Unit 5, which is energy and motion. We're actually, and I know you guys probably don't pay a lot of attention to this, but we did Lesson 1. We're just finishing that up with redos and everything. We're going to skip Lesson 2 just because of the whole year and how it's going due to time. And we're going to move on to Lesson 3. And what Lesson 3 about is this. It's how our distance, time, and speed all related, and how you can use those terms so that you use them in the correct way, and then actually how to calculate or how to figure out those things. So we have some objectives that hopefully by the end of next week or in 2 weeks, you'll be able to complete. All right. The first one is you will be able to say, I can differentiate between speed and average speed. And we'll have lots of examples of that. And then you can calculate the average speed. Okay. And we'll even actually talk about that today. Then we will be able to look at graphs that show how far we've gone versus the time. So say you leave home here and we drive to Polaris Mall, how much our distance goes depending on how long it takes. Next, you'll be able to analyze or judge the relationship between speed and the steepness on a graph, how much the line goes up, how much the speed goes up. And then you'll be able to tell between speed and velocity. All right. So we have one standard on this, and that is an object speed is described by its speed and the direction in which it's moving. And then also the math and data that goes with that. We're most worried about this one. Okay. So let's look at this, engage your brain. A dog usually moves faster than a bug, we hope. That means if I watch them move for 1 minute, then the dog would have traveled a greater or smaller distance than the bug. I think our common sense would tell us it is greater. All right. However, a car usually goes faster or slower than a dog. Again, I think our common sense would tell us faster. If the car and the dog both traveled to the end of the road, then the car or the dog would get there first. Well, the car's going faster, so the car is going to get there first. Those are just kind of some common sense stuff. All right, next, they would like you to draw or sketch something that you might see move. Write a caption that answers the following questions. How would you describe its motion? Is it moving at a constant speed, or does it speed up and slow down? So just think real quickly in your head, something that would move, describe how it's moving, its motion, and would it be at a constant speed or speeding up and slowing down? All right, well, they use the example of Usain Bolt, who's that famous track guy, okay, and he won in the Olympics by an incredible distance. And their caption was this: the sprinters are all running faster than 23 miles an hour, but decelerating as they near the finish line because they're slowing down after they've sped up. So there we go. All right. Now we want to look at some active reading questions. We're going to fill in the blank. If an object changes its position, then it is in motion or moving. Good. The speed of a car describes, think to yourself for a second, what could the speed of a car describe? How fast it can move. All right, so now we're going to get into the actual notes. You will have questions following this, so you might want to jot down some notes with the vocabulary here. All right, so how can you describe the location? In order to talk about speed or average speed or the distance something's going, we have to be able to identify where it starts and where it stops. So identifying a location, you need to have a position and then what also is called a reference point. Okay, the first word, and you will have a question about this when you get to the questions, is position. And a position describes the location of an object. We'll do an activity here in just a second. but that's what position does or explains. And identifying the position of an object requires a comparison of a nearby different object. And we're going to look at that in just 1 second. Okay. So the next word you need to know it, and it's a question a little bit. When you describe a position by comparing it to the location of another object or place, you're using what is called a reference point. And that is a location to compare other locations to. And I know that sounds complicated, but it will become clear here in a little bit. All right. So this is actually in textbooks. If we had real school and there was no COVID, this would be on a page. Okay. So kind of visualize this. How would you describe where this question is located on the page and give 2 different answers? Well, if this were on a real page, okay, it would tell you that it's 4 paragraphs from the start of the page and 2 inches up from the bottom. Okay, so those were 2 ways to refer to it. So now let's look at this. This is a much better activity. One of your friends is at the southeast. Hopefully you know your directions. North is at the top of the page, south at the bottom, east, the wrong way. East is to the right of north and west is to the left of north. Hopefully that came out. One of your friends is at the southeast, okay? And I'll point that out in just a second, of Monkey Island. He would like to meet you. How would you describe your location to him? So he is on, there we go. I've got the pen. Maybe I have the pen. Okay, we'll see if it works here. Sorry, guys. All right, he is up here. Well, south is down here and east. So southeast is here, okay? And you are here. So how could you possibly tell him what to do? So first of all, what direction would he have to go? This is, say it to yourself, that is south. So how many blocks or squares would he need to go? 1, 2, 3. Then this is east, okay? And then he would turn east to meet you 1 block. All right, let's see how, now let's see if I can, get this off of here. Sorry, guys. All right, let's see what the book says. 3 blocks south, 1 block east. Good. All right, you need to go visit the first aid station. How would you get there? All right, so now I gotta go back to the pen, and then maybe I can get a different pen color. All right. Sorry, guys, I'm learning this as we go along. All right, so you are here, and you need to get to the first aid. This is first aid. You can see over in the key. All right, so you could go several ways. Okay, you could go 1 block. Anybody know what direction this is? That's west. And then 1 block north, as we see from our directional. And then 1, 2 blocks west. Again, there's different ways. You could just go straight this way and then up. But let's just go with our first way. All right. And they have go 1 block west, 1 block north, and then 2 blocks west. All right, so that's how you could describe things. All right, next we want to talk about motion. What is motion? Well, motion is a change in position over time. You have moved if you've gone from one spot to another. Okay, how do we measure distance? Well, in most of the world, it is kilometers. So you will hear me use kilometers a lot, or meters, or even centimeters. But we know, as Americans, we like to be different. So we use miles, feet, and inches. Okay. So again, if you see kilometers, that is close, not the same, equal to, but the metric kilometer is our mile. Okay. The meter for us is a yard, and centimeters are inches. Again, not exactly, but those are the units that correspond with each other. All right. So Here is a maze, okay? And they just show you different ways that you could get through to it. They just want to know you could do one that has a different distance, but I'm going to go on from there. All right, now probably what you most care about is speed, the need for speed, as they say. Speed of an object is a measure of how far something moves, so how far its position changes in a given amount of time. So, simply put, speed measures how quickly or slowly the object changes position. Okay? You have a gauge in your car called a speedometer, speedometer. Okay? It tells you how fast your car is going. All right. Then there's another term. Again, there'll be a question about speed and average speed on your questions for today. The speed is rarely constant, so we use what is called average speed over a length of time. Okay? So, if you think about, let's say again, just because, look, even from your house to the school, okay? You're not going the same speed the whole time. You're going to start at 0, then you might, parents, whatever bus might get up to 55 miles per hour. Okay, then we have to slow down for lights and for stop signs. Okay, that's speed. Average speed would be what you went from home unto school and the time. Okay, so if we look here, speed measures how fast an object is moving at a specific moment in time. So if you look over at the car you're in speedometer and it says 50 miles per hour, that is your speed at that second. Okay. Average speed is what your speed was over the whole time. Okay. So if we look at how average speed is calculated, it is this formula. And you're going to need to like write that down or somehow memorize it because we are going to use it a ton for the next couple weeks. Average speed is distance divided by time. Okay. So say you did go to Polaris Mall and it's 30 miles, just to make it easy, and it takes you 1 hour, you could divide that and you would get your average speed. Okay. Oh, real quickly, this is important. For us, that will usually be miles per hour. You can also do meters per second, which we'll look at some problems, but miles per hour is what's most relatable to you. All right, we'll do problems on another day. I'll talk to you about this in your daily announcements. We're going to change things up just a little bit for the third 9 weeks. This assignment is due on Tuesday, okay? I'm going to really be a lot more strict with due dates, to be honest, okay? I know things come up and you get busy and you have other classes and some of you are remote and we're all hybrid as of now. So, but I'm going to be more strict. If you are late, like over a week, then they're going to go to zeros. So we cannot get behind. You need to keep up with your work. Okay. So you should be watching this on Thursday. Okay. Go ahead and do the questions now, right after you watch the PowerPoint. Okay. Then it's taken care of and it's done, and we can go on to tomorrow's work. Okay. All right. Take care. Get this done. And we will talk later.